All right, everybody, we are on day 4 of finding more factors of a polynomial. Again, main rule, just don't get yourself frustrated. There's your example that's been kind of holding tight for all of us. And let's hop into it and see if we come across anything new, any new little rules or anything here. So we're going to go straight into our examples since we've had a lot of explanations before. Remember, when we have to write things in factored form, our first factor we need to look for is absolutely a GCF. In this case, everything divides by, well, definitely by 2, right? Maybe even by 3. 2, 3, and possibly by 6. So looking at all my numbers, my coefficients, I am going to pick 6 because 6 is the biggest thing, the biggest GCF, the common factor that goes into all of them. Now this is odd. They don't all have an X, do they? And they definitely, so like this one doesn't have an X, this one doesn't have a Y. So my greatest common factor is just a 6. Well, let's go ahead and divide it out. That's going to be 1x squared. That's going to be minus 4x with y, and that's going to be 3y squared. All right. So this is unusual for us to have x's and y's after taking out or factoring out our GCF. So that's okay. Let's just still identify what we think a, b, and c are going to be. So I see that a is my 1, my b is my negative 4, my c is 3. Don't let the extra variables mess with you, okay? So step 3, let's go ahead and let's just trust the process. Go do AC on one side, and let's do B on the other. So AC is 1 times 3 and B is negative 4. So, excuse me, yeah, so that's 3 with a negative 4. 1, 2, 3, 4, 5. Remember the process. We're going to divide 3 by 1 and get 3. We're going to add those to get 4. Okay, I'm done. Now I know I need a negative 4, right? So I can just switch, switch, and switch, and there's my magic numbers. Now, listen, let's go into our box, but let's just kind of point something out special that happens inside the box that we have not seen. So remember, I told you every day I'm just going to add a little bit more and go from there. So my top left of my box is still going to be 1x squared. So 1x squared goes in there. The bottom right, this is odd. I'm used to just seeing like a 3 here, but this time I have a 3y squared from up top. All right, don't let that bug you. You know your magic factors are negative 1 and negative 3. And instead of just getting an x, so it got half of this variable, right? So instead of just getting that x, half of x squared, it also needs to get half of that, which is going to be a y as well. So they get x's and they get y's. All right, we're cool. So the same process, okay? So let's find a GCF here of these items. That's going to be a 1 as my coefficient, and they both have a single x. This coefficient, the GCF is a 3, a minus from the top, and they both have a single y. This GCF is a 1, and they both have an x. And this GCF is another 1, negative from the left, and they both have a y. So it's okay if we have a double variable problem. We just have to be a little more careful with our GCFs and setting up our box. So my final answer is going to be my GCF of 6, my first binomial 1x minus 3y, and my second binomial 1x minus 1y. Please remember the state testing will not have the 1s as their coefficients. So these are my 3 factors of my original polynomial. Number 2, taking a look, trying to find my greatest common factor. There's always step 1, GCF, when it comes to finding factors. I know that 5 goes into all of those terms, and I also see that every single term has an r. So I'm going to divide by 5, take off an r. Divide by 5, take off an r. Divide by 5, take off an r. So 15 divided by 5 is going to be 3 with an r squared after I take off an r. 5 divided by 5 is 1, a single r, and a single n. And now this last one, 25 divided by 5 is a negative 5, and take off an r. So we're all done here. Now it's time for me to go to my chart, but I already see a huge problem here. When we have a double variable situation, see what I mean by a double variable situation? This last term would need to have an n for me to proceed. It's like I can't even go to my chart because this has an n, this would need an n squared. And it simply doesn't have one. So guys, there is nothing that we can do here. Like we're done. We can't finish anything. So it's not that the whole thing's prime, it's that that new trinomial is prime. So my final answer is just my 5r with my 3r squared, with my rn, and my negative 5. Again, for emphasis, since this has an n, this would need an n squared. Because this has an r, it has the r squared. That was okay. I can't even proceed, though. I can't even try to get my magic factors. This is the factored form of the original polynomial. Let's take a look at number 3. Maybe we have another one like that. That would be nice. Those move fast, huh? Sneaky, but they move fast. As always, my first factor comes from my GCF if there is one. So I do see that everything divides by a 3. That's good. And they don't all, I'm so sorry. I'm going to fix this on your paper. Yeah, I'm sorry about this. I'm going to try, maybe I'll fix this on YouTube. All right. This problem should have had x squared here and an x here. I'm going to put that there so I can take it off of YouTube. Okay, guys, I had to add an x squared and an x to mine. I redid your notes, so that's already there. So please just ignore that that's not typed in. It's typed into yours, okay? So let's take a look. We got to find our GCF. That's always how we find our first factor. And I do see every single of these items, they all divide by 3 evenly. Like 3 is your common coefficient, excuse me. And they also all have an x. Let's go through the process of dividing by 3, taking out an x. All right, if I divide by 3, I end up with a 1 and an x to the third. If I divide by, that was from here, if I divide by 3 here, I end up with a minus 1 and an x to the second. Divide by 3 here, I end up with a 2 and an x to the first. Divide by 3 here, I end up with a minus and a 3. So this is 4 terms. Have you guys gotten used to those 4 terms yet? That means you get to skip straight to the box. So let's set this box up. 1x3 goes here. Negative 3 goes here. And then this negative 1x squared and the 2x can go in either of those spots. I just chose to put them there. Now we have a GCF here of 1 and a single x. A GCF here of 1 with no x's and a minus from the top. We have a GCF here of a 1 and this time an x to the second because the smallest exponent of those two. I'm so sorry. And here we have a GCF of a 1 without an x and a positive from the left. Now, remember 4 terms can be pretty sneaky. Let me write what I think, hint, hint, is my final answer. Let me write what I think or what appears to be, it's a little misleading on this problem, my final answer. I have told you in the past that 4 terms needs to be checked. Okay, so here's how you check it. You look at right here, you go to this GCF step, and we have to do this. What does that make when you multiply? Sure enough, that does make 1x3. So I'm just going to go ahead and give this a little check. What does this one make? Well, this makes a positive 1x. Oh, no. That is not anywhere up here, is it? A positive 1x. You know what that means? That means that this box didn't work for this 4-term polynomial. That means our final answer, I'll keep the check on there. Our final answer should have just been, and you won't know until you do the check with the box method, should have been just after our GCF. So notice I'm just writing that, I'll point to it because you can't see where I'm pointing. So this, because the box did not help us properly like get the factors, that is the final factored form itself because the box did not properly help us break it apart. In other words, that polynomial was prime after I took my GCF out. All right, number 4. I don't know why that's gray, but that's okay. We'll roll with it. So we got to do our GCF first. I know they both divide by 3, and they definitely don't have a P or a K. So it's okay, just divide by 3. So that's going to be a 4P squared, take away a 1K squared. Now this one's just 2 terms. All right, this one's just 2 terms. So with 2 terms, when you go to find, you still have to do ABC. A is going to be your first number in front of your first quadratic. C is your last number in front of your last one. And B is the one that's 0. See how there's no like PK term where they're joined up? That makes it 0. So I'm going to do my AC and my B chart. AC is -4 and B is 0. I had to find my 2 magic factors. So again, if you don't know them right off the bat, just start with 1, 2, 3, 4, and 5. -4 divided by 1 is -4. Add to be -3. So those are not it. -4 divided by 2 is -2. Add those to get 0. There it is. Now jump to the box. We kind of have to be careful when we set up this box, okay? So in the top left, as always, it's 4P squared. Go to your GCF step. I have seen kids putting this 3 in there, so don't do that. Your last box is the -1K squared. Now your catty corner boxes are 2 and -2. Remember I gave you this one rule. Now this is new today. It gets half of this variable and half of this variable. So it gets a single P and a single K. I'll get rid of those highlights. So that's how you kind of work those ones out, okay? Now it's time for a GCF here and here. So my GCF on the first one is a 2 and a single P. My GCF on the second one is a 1 and a single K and a negative from the top. My GCF here and here are a 2 and a single P. And my GCF on the bottom is a 1 with a single K and a positive from the left. I have this finally factored. My factors are 3 from my GCF, a 2P minus 1K, whoa, that's messy, and a 2P plus 1K. This was originally called the sum of perfect, or the difference of perfect squares. If you see that, that's great. If you don't, that's also perfectly fine. So this one has been factored to 3 different factors. Let's take a look at number 5. So we have a 4 term here happening on number 5. We're going to always look for our GCF first. It might be tempting to divide by 6 or by 4 or by 3 or by 2 or by 1. One of those is definitely it. So just check. Does 4 divide by 6? Nope. Does 4 divide by 4, 20 divide by 4, 6 divide by 4? Nope. All right. Does 4 divide by 3, 20 divide? Nope. And does 4 divide by 2, 20 divide? Yes, 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 I found it. So my answer is going to be a 2. My GCF in this case is a 2. So every item needs to be divided by 2. Now, do they all have an X? Mm-mm. Do they all have a Y? Mm-mm. So I'm just going to go straight into my dividing by 2. Oh, sneaky, sneaky. Did anybody catch that the first term was negative? That means my GCF is not just 2, it has to be a -2. Let's fix that up. Anytime your first term is negative, please take a negative out. All right, so that's going to be a positive 2x squared y, a positive 10x squared, a negative 3y, and a negative 15. And all of that came from dividing each term by -2. I see 4 terms here. So 4 terms lets me go straight into the box. Remember, don't use your original polynomial. Use this polynomial right here. So 2x squared y, well, that's weird looking, isn't it? Negative 15, that came from here and here. 10x squared can go either here, and 3y can go here, or you can switch those two. Let's see what we end up with here. We're going to have to check this one and see if it's legit. So a GCF there is a 1 from the numbers, or the coefficients, and a y. A GCF here is going to be a 5 from the coefficients, and a positive from the top, and no x's. A GCF here is going to be a 2 and an x squared. And a GCF here is going to be a 3 and a negative from the front with no y's. So let's write this and then check it. Okay, so I'm going to use my GCF of -2, my binomial that I got, and my other binomial that I got. And I do have to check this. So let's see, that's going to make a 2x squared y. Let me get my check ready because I think I'm good on that one. Check. This is going to be a minus 3y. Check. This is going to be a plus 10x squared. Check. And this is going to be a minus 15. Check. Okay, so this one was legit, unlike the last one that we did with 4 terms. This one checks back in, so my final factored form is right here. Okay, number 6. I am going to take a look for my GCF as always. That's my first factor I try. The only thing all those divide by, it's not by 3, right? And it's definitely not by 8, and not by 2. And they don't even all have an x or a y. So my GCF would simply be 1. So I'm not even going to like worry about it. I guess I could, if you want me to, I can divide by 1, but the keystones won't expect you to. Dividing by 1 legit does absolutely nothing. All right, so now I'm going to move to A being 3, B 10, C -8. AC is -24 and B is 10. When you multiply and then you get your 10. 1, 2, 3, 4, 5. And now it's time to divide. -24 divided by 1 is -24. Add -23. So these do not add to be the right answer. -24 divided by 2, -12. Add those two, and you get -10. Oh, okay, I got it. So I got the right thing when I added them, but the wrong sign. So we change, change, change. Change out all the signs and you'll be good to go because you still get your -24, but now you got your positive 10. All right, let me find my step right there. 3x squared goes here. -8y squared goes here. Don't worry about the double variable. We're doing fine. -2 and 12 go here from my magic numbers right here. These get half the x, so x, and y, and y. So half of this variable and half of this variable. This is a double variable problem. GCF here is a 1 and a single x. GCF here is a, let's take a look, 8 and 12, that would be a 4, and a single y, and a plus from the top. GCF here is a 3, and they both have a single x. GCF here is a 2, and they both have a single y, and then a minus from the left. Final answer is my GCF of 1 from the beginning, 1x plus 4y, 3x take away 2y. Remember, the keystones will not have this one or this one. So this one actually only has 2 legit factors of x plus 4y, and that's getting messy, I don't like that. There we go. X plus 4y and 3x minus 2y. And so that one only has 2 factors. And that is the end of 8-8. I think I'll probably have one more day because there's some other stuff that I want to show you that might happen.